I'll start with a quick review for this book, Mystery of Modern Physics, Time. The book is about time. It's about one of the great courses. I'll give this book 3 out of 5. I almost gave it a 4, so the first half of the book was really good, and I thought about giving this a 4. And then the second part started to be more speculative and has not direct relation to time, so we was down to 3. But it could be good. It could be good. He's a really good lecturer, really good professor, easy to understand, and some interesting ideas in time. I couldn't say that I know what time is now. It's an extremely complicated idea, a concept, but a little more. I have a little more knowledge about what time is, which I wish not necessarily they know what's going on, but a little better idea of what time is. Let's see the notes. We all know what time is, but it's really hard to define. So it's really hard to define what time actually is. We all know what it is, we feel it, but it's really hard to define. A clock is something that do the same thing over and over. So what a clock does is doing the same thing over and over. That's how you measure time. It has to be the same thing over time. Time is the 4th dimension. So we have X, Y, and Z. That's 3 dimensions. And time is the 4th dimension. When you want to meet someone, you would tell them a coordinate, and you have to say a time. So that's the 4th dimension. Calculating the time correctly was a big issue before technologies was developed, since temperature, location, and other things were interpreting clocks. So the clock is something that measures things over and over, the same thing. But before they had technologies like quartz, I think they use quartz, and other technologies, atomic clocks they have. But temperature, location, and other things were interrupting the clocks because they changes a little bit. The temperature changes things a little bit, humidity, location, where you are, they all changes the time a little bit, so it was hard to actually measure time. The fact we can change the future has relation to the era of time. The era of time go forward in some way. If you look on the x-axis, you look from left to right. And the fact we can change the future, because we have, and we cannot change the past, has relation to the era of time that goes this way. The irreversibility of time is a consequence of the nature of matter, entropy. There's a typo here, entropy. Not the nature of time itself. Time does not necessarily has an arrow. So the fact that time is irreversible is a consequence of time itself, so entropy. It goes up. There is much more notes about it. But it's not because time itself. So theoretically speaking, time does not necessarily has an arrow, so it could go backwards in some way. That's why they're talking about time travel. So that doesn't mean that time itself has a limitation of where it goes. It's entropy that limits the where time goes. The nature of matter has the universe, and the universe is entropy. That is, the things to get more disorganized. That's the nature of matter, to things to go more, it's a chaos in some way. It becomes more disorganized, more dispersed. That's entropy. The second law of thermodynamics is that in a closed system, entropy either stays constant or goes up. In a closed system, it will go up or stay constant. Entropy always grows in some way. Heat is creating entropy, as it's easier to heat than cool. Cooling is done by expanding gas in a process that creates heat. So in general, heat is creating entropy because it's easier to create heat than cooling something down. How do you cool something down? By creating heat. So it's really hard to cool something down. Systems and other things are mostly not reversible. You cannot reverse. That's the same idea of time in some way. You cannot reverse it. It's much more problematic. You open the egg, you find an egg, it's really hard to reverse it back. Quantum mechanics can predict positions using probabilities only. That's how they do. They use probabilities, and that's how they predict the position, by probabilities. They can know for sure. It has a 90% probability of being here, 10% probability of being there. They don't know exactly. Particles are in superstate. That is, the probability to be in one of two places until observed. After that, the position has been fixed. So before observed, particles are in superstate. They have the probability or it can be in two places. I think they said they can be in two places at one time. I don't think that's the idea. It's like you don't know exactly where it is. It has probability of being here and there. But the thing is, the interesting thing is, which I still do not understand, is that after you observed it, it's fixed. You, in some way, you have interaction with it. You made it to be fixed. So it's no longer could be in two places. It's right there. Weird stuff, for me at least. Entropy happens as there is more possibilities to be that way. When fluids balance themselves, it's in the most entropy place, and there's a lot of typos here. Didn't do a good job. Where most options occur. So what happens? Entropy happens why there is entropy? Because that's where the most options, or that's where the most possibilities occur. So when you have 2 gallons or something, and you have something between them, they will balance themselves out eventually. And that's where entropy is the highest, because that creates the most possibilities for fluids to be. They can be here, they can be there, they can be 99.9 here and 1 point there. That's the most possibilities, and that's where entropy is the highest. When we burn energy, we cause molecules to move faster, we create heat as entropy goes up. So what happens when we burn energy? We cause molecules to move faster, that creates heat, and entropy goes up. So that's why we cause entropy to go up in some way. When we burn energy, we cause entropy to go up. Entropy is essentially how many configurations possible. The more, the higher the entropy. That's a similar idea. The more possibility there is, the higher the entropy. The past has less options than the future, which is why entropy was lower. So there is less options. Therefore, the past has less entropy, and the future will have more, because there is more possibilities for the future, less to the past. Entropy was lower in the past. That's a side note. Before this side note is that this book, half of the book I would say, is talking about entropy. It's entropy, entropy, and entropy. Back to this side note, author is too philosophical at times. Sometimes it's way too philosophical for me. And I was kind of like, what are you talking about? And that's more towards the second half of the book. We get low entropy energy from the sun and radiate back higher entropy radiation. So we get low energy from the sun and we radiate back low entropy, and we radiate back higher entropy. So we in some way cause more entropy. Every mammalian species have an average of 1.5 billion heartbeats. I heard about 2 billion or 3. I think I even heard about 3 billion, I think. But in general, it's like could also use as a clock. And most of them, doesn't matter the size, we all get 1.5. Some of them move faster and they die faster, and some of them have slower heartbeats, like elephants, they live longer. The heart rate is one of the rhythms that is helping us track times. So you can sometimes track times. It's something that goes over and over. It's a clock in some way, but the problem is that it's not the same always, but it's still helping us track time. When we're focused, our inner clock moves faster. As we think, less time has passed. When it's boring, the opposite occurs. So when we're focused, our inner clock moves faster than the general. And therefore, we think less time has passed. When it's boring, the opposite occurs. It's kind of hard to exactly wrap your hand around these ideas, but there is more notes. According to one theory, time seems as moving slower when we pay more attention to details. That's what happens. We think time moves slower when we pay more attention to details. Situations such as when our life is dependent on it, everyone are when you fall out of a plane or something like that, when you bungee jump. People report about time that is moving slower. What's happening is that we pay more attention to details, time looks as it moves slower. And if we go back to this, our inner clock moves faster then, and we pay more attention to details, we think less time has passed. It's an inverse relation. As kids, we might feel time is moving slower since we pay more attention to details as it's all new to us. Added the number sign here as it's an interesting part. Is because as kids, time looks like it's moving way slower than we are in adults. According to a theory is that because we pay more attention to everything, everything is new to us, time seems as it moves slower. And when we're adults, we're used to everything already. It's the same thing over and over. Time looks as it moves fast. According to one theory, the possibility to think about the future arises when living on higher ground enable us a lot of typos, enable us to see more things and therefore contemplate the future. So when we moved into the ground, especially higher ground, we were able to see around us. So on a mountain, you actually see things, and then we started to contemplate the future. And this is how we are who we are in some way. Start to contemplate the future, understand that we can plan. Our brain is functioning more as a committee than a top-down. So there is more committee. It doesn't have like a one person. It's not like a CEO. It's more of a committee. It's not only here. It's general knowledge. There's a lot of that on neuroscience books. Side note: the author is good at explaining basic ideas. I'll give that to him. Really good about explaining ideas in a very simple form, diverting your attention to what's important and what's not. Newton's space-time is obsolete, meaning that time is same everywhere, while Einstein's time is relative to the observer. So that's the difference between them. For Einstein is relative, depends on where you are, who you are. And for Newton, time is time, doesn't matter where. A second is a second. According to Einstein, time moves definitely depend on the location in space. That's the relative idea. It depends where you are, time will move differently. According to Einstein, matter and energy creates gravity. That's gravity is because of matter and energy. They create gravity. Some complicated ideas that I still have a hard time actually wrapping my hand around. Time travel would work if we go into the future of the light to see our past. We have like an idea of the light cone. So if we go into that light cone to the future so fast that we will see our past, we will come back to our past. That's how time travel would work. That's the philosophical part, second part of the book that I liked less. So it's much more speculative. Side note: the second part of the book is more speculative and not as good. That's what I just said. It's not as good. A lot of speculations, a lot of unconfirmed ideas. Sometimes good to hear, but a little too much for me. It was a little too much. Vacuum energy is the most basic energy that exists everywhere. That's like a most basic form of energy, vacuum energy, because even in a vacuum, there is a little bit of energy. That's vacuum energy, they call it. According to one theory, time was created with the universe. Another theory raised the possibility of a bouncing universe, that is, Before was a universe that was contracting. So it's like two theories. One of them time created with the universe. That's a byproduct in some way of the creation of the universe, but with it. Another theory raised the possibility of bouncing universe, which is a universe that keeps going up and down and contracting, expanding, contracting, expanding. It's a good theory. The universe seems to be flat, which is an interesting idea. It seems everything seems flat. He has some ideas of why and how. I didn't get into it, but it seems interesting. Side note, the second part of the book has little relation to time and is pure speculation. The relation between that to time is less and less, and as like I seen, like since the second part is like slowly but surely goes down, and that's not necessarily relation to time, what time is. They got a little bit off of it, multiverse and things that are not necessarily related. According to one theory, our universe is such that had low entropy at first, but it's not always must be that way. Like that theory is like, because they can't explain why entropy was lower in the past. It tried many theories, none worked. So when going to that theory, our universe is such that was at low entropy in the past, but it's not necessarily has to be that way. So theoretically, a different universe could start with high entropy and goes to low entropy, things like that. That's it for the notes. Again, some interesting part. I definitely learned some things from the book. I wish the first part of the book was longer, and I would drop at least most of the second part of the book. But if you're interested in time and you don't care about physics, I would recommend this book or course. Thank you.